So now it's time for the session with Dr. Laura Garcia Hernandez. Dr. Laura Garcia Hernandez is an associate professor in the area of project management at the University of Cordoba, Spain. She received her PhD in the field of engineering in 2011 from the University of Cordoba. Dr. Laura's primary areas of research are engineering design optimization, intelligent systems, machine learning, user adaptive systems, interactive evolutionary computation, risk prevention, and educational technology. In these fields, she has co-authored more than 80 research publications. She has given several invited talks in different countries. She has won the Young Researcher Award granted by the Spanish Association of Engineering Projects in 2015. She has won 2 times the General Council of Official Colleges Award at prestigious International Conference on Project Management and Engineering, both 2017 and 2018 editions. She has been the investigator principal in 2 Spanish research projects, and she has been investigator collaborator in some research contracts and projects. She is a regular reviewer for more than 20 international journals indexed by Thomson ISI and is actively involved in the committee program of several international conferences. Ma'am, we welcome you to the family of PPIT and to the family of ICFOS. Over to you, Laura, ma'am.
Hello, everyone.
Hello, ma'am.
Hello,
Can
ma'am.
you
Good
hear
afternoon.
me? Okay. Can you hear me?
Hello, Dr. Lyra.
Yes, ma'am.
Thanks for this presentation. Is for me it's an honor to give a speech in your webinar, and I will talk about the optimization in facility layout problems. And I will speak about our recent investigation related to bio-inspired algorithms for doing optimization in facility layout problems. I am Laura Garcia Hernandez. I am professor in the University of Cordoba in Spain. Specifically, I am working in the area of project engineering and project management. And I will give you an introduction about the facility layout problems. Sorry, because no, okay. First, as I told you, I will speak about an introduction related to facility layout design. I will talk about the different facility layout problems, and also I will speak about the way to solve these problems, mainly using genetic algorithms, and also I will speak about some of our works that use island genetic algorithms, also another bio-inspired meta-heuristics that is related to the coral reefs optimization algorithm. I will continue with our interactive proposal that allows to consider the decision maker preferences in the layout. That is the first time that had been considered in this kind of problems. And then I will continue with the multi-objective proposal that combines not only the quantitative factors of features, features, even also consider the qualitative, the experience, the decision maker preferences into the approach. And finally, I will speak about our recent inclusion in the proposal about an eye tracker that try to introduce the decision maker preferences using the gaze behavior. And I will do concluding remarks on also our future research lines or possible future research lines. And finally, I will show some publications or related publications about all this content. Facility layout design, try to determine the placement. Sorry, because I take something here, sorry. The correct placement in a manufacturing plant. It is important to put the facilities in the most effective way, because this distribution will affect, for example, to the production efficiency, also manufacturing costs, lead times, to the work in progress, and also the productivity. Sorry, because when I push enter, the system asked me for shutdown. Sorry. There are many facility layout problems, and they are determined by, for example, the workshop characteristic, layout representations, or the resolution approaches. So, for example, talking related to the workshop characteristic, we have the facility shapes or dimensions, which material handling system we have. We can have production system that are static in the time, or we can have, for example, productions that depend on the season we have, for example, Christmas, summertime. Also, we have some layout representations. It can be, for example, continuous or discrete. And we can have different type of resolution approach. It can be exact procedures or approximate approaches. Here we are focused in the workshop characteristics, and we can have so many problems depending of the considerations we have. For example, if we have a loop, a material system, handling system with a loop or a single row, we have so many features that can determine different problems. According to the layout representation, as I told before, we have two different representations. Yes, we can have continuous or we can have discrete. And for example, if we have a continuous representation, we can have by structure, and also we can have the slicing tree. The most used is the structure of bytes, and this structure divides the plant into portions, and then each facility is allocated in each portion until this bay is complete. And the following representation is related to the slicing tree. Continuous representation is related to slicing tree, where we have a tree structure for dividing the plant layout. This is a structure that is normally less used for solving these problems, because it has is more complex than the device, and normally is less used. And finally, we have the discrete representation, where the plan layout is divided into squares, and then we need to an additional structure and a space filling curve or something to associate each square to the associate facility. Okay, according to the resolution approaches, we can have two main categories. First one, exact procedure. For example, graph theory, integer programming, etc. But these procedures, this problem is NP complex, so we have only a solution, optimal solution for facilities, for problems that have 12 facilities. So the most used is the approximated approaches, and we can have for different classifications. For example, we can have heuristic methods, we can have meta-heuristic methods, and other kinds. Okay. Specifically, we are focused in a problem that is called the unequal area facility layout problem. This is one of the problems that have been more addressed by authors. It was formulated by Armour and Buffa, and it is based in a rectangular region with fixed dimensions and a collection of a number of rectangular facilities that has a specified area. For each of this facility, it is associated material flow between each pair of facilities. The aim is to partition the region into subregions with appropriate area to minimize the total cost of material handling cost movements. We have a constraint that the sum of the facility areas must be less or equal of the total layout area, and the overlap between facilities is not allowed. First, for addressing this problem, we have used, firstly, we have been used genetic algorithms. This algorithm, the genetic algorithms, was the most used method for solving this problem, the unequal area facility layout problem. Is a meta-heuristic search that is based on a natural evolution, and each individual represents a solution. It had been widely applied, as I told before. Here we can see a simple schedule of the genetic algorithm, and I will show how we have applied to this problem. Also, for genetic algorithms, we have did a study about the encoding schemes that were used in order to reach a determined function. So we have identified which possibilities we have to test new things. For example, we see for place that we have some plots permutations or integer permutation and so on. This way we see the things that have been applied in literature, the things or the functions that or operators that they can be applied, but they have been not yet, and what the functions or the operators that it's not possible to apply because of their nature. So we test different possibilities. Our objective function is based in the material flow, and we can see that this is the way the things we can optimize. We want to optimize. So we have a flow between each pair of facilities. Also, we have a distance that it can be Euclidean or rectilinear. Also, we consider the possibility that a facility can be feasible or not, because for us it's not a good solution, a solution that has, for example, only 1 meter of height, or we need an aspect ratio, so we need to satisfy an aspect ratio, and our objective functions take into account that the facilities that are in the layout will be feasible. Okay. This formulation of the objective function was taken from Tate and Smith, and it has been applied, mostly applied. We have solved the problem of the facility layout problem, considering a model that is based in an island genetic algorithm, where we have an independent multiple subpopulations. This helps to preserve genetic diversity. So we try to avoid local optima. Also has this model has the advantage of exploring multiple search trajectories, and we have reached better search performance. We have reached better results because we have compared our model with the sequential single population models, and normally we have better results. Here I am displaying a data set with 20 facilities, where we can see our comparison between our island model with the best solutions known until now. Also, we have displayed the graphical representation of this layout. Following with bio-inspired algorithms, we have applied a new, relatively new methodistic. It was proposed by Salcedo-San et al. In 2014. It's called coral reefs optimization algorithm. This model is an evolutionary type algorithm, which evolution is guided by imitating process occurring in real coral reefs, such reproduction, the fight for the space, and also, for example, predation. It's a kind of hybrid evolutionary algorithm, and also simulating annealing, but it has been applied to many problems, optimization problems, and this method heuristic have reached better performance than both techniques in these problems. So for us, we have applied this coral reef optimization algorithm, and it's based in these steps. We can see that first we have the reef initialization, then we select the broadcast spawners, and we have applied the broadcast spawning. We have the sexual crossover. So in this model, in this heuristic, we have sexual reproduction and also asexual reproduction, because we have later the brooding step, again the larvae setting, and the asexual reproduction using budding or fermentation of an individual. And if the stop criteria is achieved, the process ends. If not, depredation phase occurs with a very low probability, and the process goes to the broadcast spawning again. We can see that the application of this method heuristic to the facility layout, the unequal area facility layout problem, have reached very good results if we compare with the best known results until the moment. We have applied this method heuristic to problems that has from 7 facilities till 62, and we have reached a very good results. We have reached the best solution in the majority of the problems, and this is related to the quantitative criteria. When we consider as a material handling cost as objective function, but we have also another possible considerations. We are talking about qualitative considerations that are wanted for the decision maker. So, for example, it is very important to consider the experience, the knowledge from the decision maker, and this is very difficult to include with a classical heuristic function or algorithm. So, for us, it's very important, and we have seen that is this knowledge haven't taken into account. It have not been considered before. Considering this decision maker experience and knowledge is essential for us, and this can be, for example, preference about locations, the distribution of remaining spaces, a certain facility orientation, preferences about locations to avoid, or any other thing or preference, any other preference that can be interesting for the decision maker in the plan layout. Additionally, it is interesting the consideration that that certain preference can be not known in advance. It can appears during the process, and also it can change, because, for example, if we see something, some solution that we didn't think before, it is interesting for us to consider. It's good to allow to the process to change the solutions during the process. Finally, we have designs that are more creative, original, and practical. Also, to consider the decision maker preferences can give us additional advantages, as, for example, the inclusion of the expert knowledge, to reach satisfactory solutions that are satisfactory for the decision maker and not necessarily are the optimal solutions. For example, we can have the opportunity to select the best trade-offs of solution when we have a conflict between objectives. Including the decision maker into the approach allow to guide the search process to the user preferences, allow also to eliminate the need to specify all the information in advance, and stimulate also gives the possibility of stimulate the user's creativity and obtaining original, innovative, and practical solutions. We have incorporated a system that is interactive, where the decision maker is included, and we need also clustering in order to classify the solutions, different plans layout, and only show to the decision maker the representative of each cluster. Here we have a schedule where we can see that the process of the interactive algorithm. So to the decision maker, we have analyzed which is this number of solutions that is more ergonomic, and is 9 solutions. So we show in each screenshot, we show 9 solutions, and we take in the qualification of the mark in order to keep in mind which solutions are good or are satisfactory for the decision maker or not, and also if we have more interest in these solutions or not. So using these qualifications, we calculate the qualification of each solutions in the population. In this context, it is very important to show the solutions in a visual design, a good visual design. So we have done an ergonomic study, and we have decided the way to show the flow, the distance request, or aspect ratio form. So using some symbols like, for example, blue lines, red lines, or a facility color in soft red. That means that is in a visual information important that allows to the decision maker see if this solution is interesting for him or not. So this slide show how we have encoded a solution. We have the genotype, that is a sequence, a facility sequence, and it is based in 2 segments. The first one is the facility sequence. The second one is the cut division of vice. And also we take in information that is important for us, like the flow, the adjacency request, the distance request, etc. And we have the subjective evaluation for each individual. This information is only put for the element that is the representative in each cluster, and for the remaining ones, it is calculated using a the membership grade of each individual to each cluster, and also the mark assigned by the decision maker to the representative element of each cluster. Then we have we have done an empirical evaluation. This test is not possible to do in a massive way because the decision maker is involved. So it is difficult to untitled for him. So it way done in this way with we test different problems, Unequal area facility problems that are taken from the real problems, and each set of tests was repeated 3 times. Also, we have turned some parameters. Okay, for example, in this problem, in this test, we have some decision maker preference, like we have 4 preferences. So we have that the blocks of the remaining space were dispersed in the layout, not joined. The layout was divided in 4 bytes, or the facility C must be exterior, and the higher dimension of the facility A must be parallel to another one. So we test these problems. Some of them was taken from literature. For example, the problem taken from the yellow that has 20 facilities. And we take also 3 real cases of the unequal area facility layout problem. An slaughterhouse in Cordoba, and also two layouts about chopped plastics and carton packs. We reached very good results with our approach. So finally, we decide to combine. This is this table, so that we have reached all the preferences that were desired by the decision maker, and this open or idea of combining the proposal to have the consideration of quantitative characteristics, features like material handling costs, and also the qualitative characteristics. So in this, for us, now we have a new way to measure the solutions, and we have an acceptable solution of the design if we have a good solutions that satisfy the qualitative criteria of the decision maker, and also reach very good results, quantitative results. Here we have a schedule of the multi-objective interactive genetic algorithm, and it was the first multi-objective interactive algorithm. And we have a part that is combining with a genetic algorithm in order to take feasible individuals with good flow values. Then we have classified the solutions into different clustering in order to show the representative element to the decision maker for taking in the mark of this element and try to keep the decision maker preferences. And then we have applied some selection methods, crossovers, mutation operators. And this process is repeated until the stop criteria. With this proposal, we reached very good solutions in terms of material handling costs, and additionally, we reach solutions that are able to satisfy all the decision maker preferences. So this was an advance for us. However, we identify a lack in this interactive algorithm. The decision maker ends the process so tired and exhausted. So we thought in a possible improvement, and we include an eye tracker. So with this device is able, we try to capture the information and the preferences of the decision maker using the gaze behavior. The eye tracking is a new technology for the study of the movement and behavior of the eyes to various stimuli. This biometric technique allows recording and decoding psychological information about attention, and with the support of other techniques, providing information linked to emotion, surprise or attraction, and another cognitive process. Eye tracking device can record information from 5 different variables: 8 fixation, saccades, visual paths, flickering, a pupil dilation. So, including an eye tracking into approach allow to eliminate the decision maker explicit evaluation. Is more sought for him, because it is needed that the decision maker only see the screen and the different plan layouts that are displayed. Here we have an example of eye tracker. We have used Toby, and this is the device. We test the device that we have used for testing the approach. So now we have we generate and evaluate a random population, and we select some elements. We do the crossovers and mutation operators. We have the evaluations, and again we repeat to select again. And we can see here the decision maker, how he is seeing the screen and also the plan layout. So instead we need to include each mark. He only will see the screen, and when he ends, he touch one time to the mouse. The eye tracker gives us some parameters. For example, here we have an image, a heat map, where the decision maker put his gaze. So we can see his gaze behavior, and we have for the genetic algorithm process the following in gaze parameters that has been recorded for cats, the decision maker evaluation, or MAC. So we have the time to the first fixation, the total fixation duration, the fixation count, total visit duration, and the visit count. With these parameters, we can extract the information, important information, in order to put a mark for each element. And then we extrapolate, considering how near is this element with the remaining elements of this group. As concluding remark, we can see that the revision about the unequal area facility layout problem, and also about the facility layout problems in general, is an open and active area. We have proposed some approach that are based on islands genetic algorithms, and also in proposals that are using that have used coral reef optimization, and we have reached very good results considering quantitative criteria. In exactly, we are talking about material flow, and also I have seen the same. We have reached very good results using islands, using also the coral reef optimization. Also, we have combined the islands with coral reefs, and we have reached very good results. Also, we take the possibility of considering the decision maker preferences through an interactive algorithm that was an improvement, because until the date, never these considerations were not taken into account. So now we have the possibility also to consider decision maker preferences. Then we have reached some proposals that are able to have a very good result, objective, considering the material flow as objective, and also to consider the decision maker preferences. We have seen that new interests could appear, and the solutions are more original, and stimulate new solutions and new designs. And now we have solutions that satisfy not only the quantitative criteria, also we have solutions that satisfy quantitative and qualitative criteria. That is very interesting in real life designs. Related to the techniques I have talked, we have reached solutions judged as acceptable by the decision maker in all test cases. So this is very good. Interactive approach we have discovered that the interactive approach have the disadvantage that the decision maker ends up tired and saturated. So we have included the eye tracker, and we have proposed an eye tracking interactive approach. And this all these improvements has been applied and has been tested for a total of different, more than 30 different well-known cases, and also in real life cases of the decision of the Unequal area facility layout problem. And we can see that we have been able to reach a solution, a good solutions, using the eye tracker, and we could reach his preferences without asking anything about his preference or his her designs. As future research work, we are thinking about the application to another facility layout taxonomies. For example, we are thinking about to apply our methods to a multi-floor problem, or to apply this methodology to the problem of the dynamic problem that has different requirements of production or material handling costs depending on the season we have in the year. Also, we are thinking about is employing the slicing tree structure as layout representation. This can enrich the designs because it is possible to have more variety of solutions, but it's more complex. Also, we are thinking about the possibility of incorporation the additional constraints or devices like inner walls or aisles, elevators, etc. We are thinking about to apply the proposed approaches to different layout problems, and also developing new approach that use recent heuristics and that has good results in different optimization problems. And also we are thinking about the parallel computation. Following with the future work research possible lines, we are thinking about to improve the reduction of the decision maker using the eye tracker and also incorporating a learning system. We want to study and also to evaluate different alternative methods of offering visual information. We are thinking also to implement a collaborative system for introducing the knowledge and experience of different and several decision makers into the approaches. And we want to investigate new techniques for preserving the diversity in the solutions. This presentation is ending with all related publications and recent publications. We have some, for example, in IEEE access, also in engineering applications of artificial intelligence. Also, we have another publications in swarm and evolutionary computations. In neural computing and applications, and so on, we have some. If you are interested in a publication, I can give you information about, or give you a paper, the paper if you need something. Just tell me, please. I want to say thanks for your attention, and I am if you need something, if you have any question, it is my pleasure to reply you. There is a question.
Thank you so much, ma'am. Yeah, I'll ask the audience if they have any questions regarding the facility layout and the optimization problems. So, ma'am, one question that is coming up to us is regarding the use of, since you've talked about genetic algorithms, they are intended to ask how differential evolution can be used in a facility layout problem. If you can throw some light on this.
Sorry, can you ask me again, please?
Yeah, sure. Somebody is asking for the use of differential evolution to the problem of facility layout. Has it been
Yes.
applied?
No, it never been applied. This is one of the things I want to, is one of our future lines, possible future lines. We have we have thought about to apply it because it has with this technique results is in the optimization. Sorry, this technique gives very good results when it's applied to optimization problems. So we think it could be nice to test it. It's a possible future line.
Thank you, ma'am. One more question we'll take, and they're asking about the convergence of the optimization algorithms in a facility layout problem. Is it a hard problem or it comes out as something which is easy to determine?
Is a complex problem because, for example, if we have normally we don't have a plan layout problem with only 8 or 10 facilities. For example, you can imagine a hospital, for example. You have many facilities to distribute. You have so many also movements and requirements of material handling cost, material flow. For example, you can have flow of persons, flow of people. You can have flow of material. So we need to distribute correctly. Additionally, we have another constraints like aspect ratio and, for example, distance or requirements. For example, it's not good to have in the slaughterhouse. It's not good to have the zone where the animals are living before killing killing them, and near to the office is, for example. So we have so many restrictions and constraints that take into consideration, and also we should think that, for example, we have problems with 64 facilities, so it's too heavy. Sometimes it's too heavy do the experimentation. And also we want also include the decision maker preferences into the knowledge into the approach. So sometimes it's difficult. And also if we want to consider more than one decision maker, it's more difficult also. So this is it's not easy.
Thank you so much, ma'am. I think that was very insightful. So as we move from technology 4.0 to 5.0, these topics of facility management and layout, the optimization, they are of very high relevance. And we have learned a lot, ma'am. Now I would request Dr. Dipali Virmani, HOD CSC, to kindly conclude.
Good evening, all. As all good things come to an end in life, so is the webinar. On the behalf of the Department of Computer Science and Engineering, VPIT, I take this opportunity to thank Dr. Laura for this wonderful session. We are really enlightened with your knowledge and presence. Our heartfelt thanks to all the participants for our active participation. With this kind words, we move to an end to the today's webinar. Thank you, Dr. Laura.
Thank you. Thank you for the invitation. My pleasure. It's an honor, and thanks to the participants.
Thank you so much. We will like to collaborate with you in future also for such webinars and some projects.
Okay, my pleasure to collaborate with you.
Yeah, our students are working in these areas. There are many projects that people are doing. As already inaugurated in the fossil, we are going to conduct many events. We will like to collaborate with you in future for such type of technology, for this technology. So participants, the form is in the chat window. Everybody of you can fill the form to get your certificates. Thank you, Dr. Laura, once again, and thank you all of you for attending this webinar.
Thank you. Have a nice evening.
Thank you. Same to you. So with this, we are coming to the end of the event. The meeting link will be active for a few minutes so that you can fill up your feedback form. For the event, we are winding off for the day. Thanks a lot.
Thank you.
Thank you.